This is Miss Hall, and today we are going to continue our exploration of rational expression rules and properties. You hopefully did simplifying in your class, and so we are going to do add and subtracting. That ends with simplifying step, which you should have already reviewed. First, a flashback, reminder, set you up for success kind of problem. Please pause the video and see if you can't do 2/3 minus 3/5 and get a fraction. No calculator, please. I hope you had enough time to do that. A note about the link, which is not a link for you, but a link at the bottom of my screen is the Khan Academy version. That would be the one that I would look for if you needed more support for rational fractions, right? So this is what my process looked like. I figured out the common denominator was 15, and then I restated 2/3 to 10/15. I restated 3/5 to 9/15. Now that they had the same denominator, I could in fact combine like terms, and I got 1/15. I hope that process seems familiar. We need to step that up into algebra functions, and again, it's the same process. They're just a little bit more complicated numbers. So I have two fractions, and I would like to add them. They currently do not have the same denominator, so that needs to be my first goal. I need a common denominator. So this first problem, I'm going to try to walk through slowly, throw in hints, reminders, and clues, and then we'll get you practicing and troubleshooting what you're doing. First step would be to factor your denominators. At this moment, you're not worried about the numerators. You have to find the common denominator. So please write this problem down and factor those two denominators before you continue. So I have my factored denominators, and again, I'm not worried about the numerators at this point. And just like the previous problem, I would need to make sure that I have the least common denominator. I don't want more than I need to work with. No sense doing quadratics if I don't need to. No sense making it a cubic if I can work with a quadratic. Same idea. So I see the factors for the first expression was x plus 4 and an x plus 1. And the factors for the second expression was a 3 and an x plus 1. So again, I would like the least common denominator to lessen the work I do. So from the first, I definitely need both x plus 4 and x plus 1. And when I look at the second one, I do not need to repeat the x plus 1. I just need to pick up the 3. So my common denominator ends up being those 3 only. And it does not matter what order you put the binomials in. Now that I know the common denominator, I'm going to need to restate my current fractions. And again, I'm hoping that's on your paper already so that you do not need to use my screen because I've made it small. So now you need to restate each fraction. And you should pause and try yourself first on your path to troubleshooting what you're doing. So my first step would be to again restate. So I would first write my two expressions with their factored denominators. Figuring out what's missing, I would multiply that using ones, so the multiplicative property of 1. So I can multiply anything by 1 and not change its value. It just changes how it looks. So these would be my multipliers. Once I multiply those in, I get this single fraction if I wanted to pull it together. So I have 3 from the first plus 5x times x plus 4 from the second, all over the common denominator. Now you worry about your numerators. So you need to simplify your numerator, combine like terms, get it cleaned up. Since that's a basic skill, I'm going to move quickly. Now, if 5x squared plus 20x plus 3 factored, we would now need to figure that out because it might factor now and simplify with the denominator. Now, there is not anything that multiplies to 15 that adds to 20. So for this problem, I have no simplification needed. That's where I'm at. That's my final answer. So we just need to clean it up if we need to, which we don't, and you need to identify domain restrictions because you are dividing by unknowns. So that also should be familiar. You could do this with interval, but at this point, we're going to do just label the terms that don't work. So give me the values for x that would prohibit this from being a real answer. Sorry, I went the wrong direction. Okay, so here we are. And again, uh, we're going to take just the x's, what values for x don't work as your restrictions to your domain. So for my case, I would need to include both -4 and -1 as they create a problem for my domain. Okay, so that's walking through pretty detailed. We're now going to keep practicing and troubleshooting until you're in a place where you can do these right.